Yo, what is up guys? Welcome back. So in this video, we're starting from absolute zero with Python. We're gonna cover how Python actually works, its history, modes, errors, and some core syntax rules. So grab your laptop, open VS Code, and let's get into it. Alright, so first things first, Python is a high-level, general-purpose programming language. Think of it like this: instead of talking to your computer in machine language, which is basically just ones and zeros, Python lets you talk to it almost like plain English. That's why it's so popular. Now here's something important: programming languages are either compiled or interpreted. Compiled means the entire code is laid into machine code before it runs. Like C or C++, it's fast, but you gotta compile first. Interpreted means the code line by line without compiling. Python does this. So you write a line, boom, it executes. Simple as that. That's basically Python in a nutshell: high level, interpreted, and super readable. Quick history lesson: don't worry, it's not boring, I promise. Python 1.0 dropped in January 1994. This was the OG version, had core functions, exception handling, and the four main data types: int, float, list, and dictionary. Then Python 2.0 came out in October 2000, introduced list comprehensions, which we'll cover later. Trust me, you'll love them. Python 2.6 released in December 2008, basically a bridge version to help devs move from 2 to 3 smoothly. And then Python 3.0, also December 2008. This was a huge redesign, not backward compatible, cleaned up a lot of old stuff, and made print a function instead of a statement. Today we use Python 3, so whenever you install Python, always go for Python 3. Okay, so Python has two modes you need to know about. First, interactive mode. You open the terminal, type Python, and boom, you're in the shell. You type one line, it runs immediately. Super useful for testing small stuff real quick, but the catch: nothing gets saved. Second, script mode, also called normal mode. This is where you write your actual code in a .py file, save it, and run the whole thing. This is what you'll use 99% of the time when building real projects. Think of interactive mode like a calculator, great for quick math. Script mode is like writing an actual program. Makes sense, right? Alright, now let's talk about errors, because trust me, you will get these. Everyone does, even senior devs. There are three types. Syntax error. This is basically a typo in your code, like you forgot to close a bracket or misspelled a keyword. Python literally cannot understand what you wrote. Easy fix though, just read the error message and fix it. Runtime error. This one happens while your code is running. Classic example: dividing by zero. Your code looks fine, starts running, then crashes midway. Zero division error. We've all been there. Logical error. This one's the sneaky one. Your code runs perfectly, no errors, but the output is wrong. Why? Because your logic was wrong. Like calculating area as length plus width instead of length times width. Code runs fine, answer is wrong. This one takes time to debug. So syntax is grammar, runtime is crash, logical is wrong answer. Got it? Let's do a quick side-by-side comparison. Execution. Compiled translates everything first, then runs. Interpreted runs line by line directly. Speed. Compiled is generally faster since it's already translated. Interpreted is a bit slower because it's translating on the fly. Error detection. Compiled catches errors before running. Interpreted catches them during runtime. But examples: C and C++ are compiled. Python, Ruby, JavaScript. Interpreted. Bottom line. Compiled is faster but less flexible. Interpreted is slower but way easier to write and debug. That's why Python is perfect for beginners and pros. Now, programming languages also have different styles or paradigms. Three main ones you need to know. Procedural. Code is written as a series of functions or steps executed one after another. Think C, Pascal, Fortran, like a recipe: step 1, step 2, step 3. Scripting, designed for automating small tasks quickly and efficiently. Python, Perl, Ruby, great for automation, web scraping, quick scripts. Object-oriented, everything is organized as objects and classes. Supports inheritance, polymorphism, all that good stuff. Java, C++, and Python support this too. The cool thing about Python, it supports all three styles. That's what makes it so versatile. Okay, comments? Super simple but super important. Comments are lines in your code that Python completely ignores. They're just for you or whoever reads your code to understand what's going on. Single line comments. Just put a hash symbol at the start. Everything after the hash on that line is ignored. Multi-line comment. Use triple quotes, either single or double. Great for commenting out big blocks of code or writing descriptions. Pro tip: always comment your code. Future you will thank present you. Trust. Alright, this one is super important in Python, probably more than any other language. In languages like C or Java, you use curly braces to define blocks of code. Python, no curly braces. Python uses indentation, literally spaces dot, so if you write an if statement and don't indent the next line, error. If you use 3 spaces instead of 4 might cause issues. Python is strict about this. Standard is 4 spaces per level. Use your tab key and make sure your editor is set to spaces, not tabs. VS Code handles this automatically, so you're good. Last topic, tokens. These are the smallest building blocks of any Python program. Keywords, reserved words Python uses for itself, like if, else, while, def, return. You can't use these as variable names. Identifiers, names you give to variables, functions, classes, like my variable or calculate total. Literals, fixed values in your code, numbers, strings, true or false. Operators, symbols that perform operations, plus, minus, equals, greater than, all that. Delimiters, symbols that structure your code, brackets, commas, colons. And that's a wrap on part 1, guys. We covered what Python is, its history, modes, errors, language types, comments, indentation, and tokens. That's a solid foundation. In part 2, we're getting into variables, data types, and operators, where the actual fun begins.